This is the first video for Algebra 1 Fall Semester Review. So the first section, 1 through 4, they're asking us to write an equation. They haven't specified what kind of equation, if we're supposed to be in point-slope form or slope-intercept form, so I'm just going to write it the way that's easiest for that particular problem. Okay, so for the first one, they gave us 2 points. So I see I have the point 2, -1, which is about there. And then 1, -7. So 2, 3, 4, 5, 6, 7. Okay, so if I count my rise over run for this problem, I see that from left to right, I'm increasing. So I'm rising 6 and I'm running 1. So I can see that I go up 6 and I go to the right 1. So my slope is 6. I'm going to use point slope form because I have a point, I know the slope. 6 over 1. So I'm going to, why don't I just use this first point? So point slope form is y minus my y value, and then the slope times x minus my x value. I have a minus minus, so I'm going to make that a plus. And there's my final answer. In number 2, I have a horizontal line through the point 9, 6. So if I think about what that looks like, 9 to the right, 6 up, and I'm a horizontal line. This has a slope of 0, so I can't really write it in any of these forms. I have to write it as y equals 6 because I have an x-intercept of, not an x-intercept, a y-intercept of 6. So all these points along this line would all have y values of 6. Okay, next problem. I have an x-intercept of -3, which is going to look like this. A y-intercept of 8, 1, 2, 3, 4, 5, 6, 7, 8. Again, positive slope through those points. If I count out my slope, rise over run, I'm going up 8, and I'm going to the right 3. So my slope is 8 over 3. Since I do have the y-intercept, I can write it in y equals mx plus b. Number 4, I'm going to refer to this graph over here. So I can also write this in y equals mx plus b because I do know the y-intercept, -3. And I got to count out my slope. So it looks like it's up 1 to the right 3. Up 1 to the right 3. Okay, graph the line y equals -4. This means that on this line, every y value is going to be -4. So 1, 2, 3, 4, and I have every y value being -4. Sorry, this should be straight. Okay. I move down so I can actually do more than one problem before erasing again. Okay, graph the line 5x minus 4y equals 16. This is called standard form. So I can get this into y equals mx plus b, so I can find my m and my b. So I can do that by solving for y, subtracting 5x from both sides, dividing by -4. Be careful here. Look at my slope. Negative divided by negative is a positive. And 16 divided by -4, let me switch colors. If I simplify that fraction, -16 divided by -4 is -4. So 1, 2, 3, 4. And I'm going up 5. 1, 2, 3, 4, 5 over 4. 1, 2, 3, 4. Okay, I'm going to cheat and connect it like this. All right, and there's my line. All right, 7, 8, 9, and 10. I really don't have room right there, so I'm going to write number 7 over here. Okay, it says solve for y. So I have 2 times the quantity y plus 3 is equal to negative 2y plus 6 plus 4y. Okay, first, distribute. Distributing my 2 gives me 2y plus 6. I'm going to combine like terms over here. Negative 2y plus 4y is 2y. It looks like I have the same thing on the left and the right, so that is going to be all real numbers or infinite solutions. Any number I plug in here for y will make these two sides equal. For example, if y is 0, 2 times 0 is 0 plus 6 is 6. Same thing on the other side. 2 times 0 is 0 plus 6 is 6. If I make y a 1, both sides would be 8. If I make y a 2, both sides would be 10. Any number is going to keep these sides equal. Okay, let's look at number 8. 5w plus 3 is equal to negative 3w plus 9 plus 2w. Okay, same thing here. I'm going to distribute 5 times w, 5w, 5 times 3 is 15. Combining like terms, negative 3w plus 2w is negative w. Okay, to get all my w's on the same side, I'm going to add w to both sides, canceling this out. Inverse operations. 5w plus w is 6w. Inverse operations again, I have plus 15. I'm going to subtract 15. I'm left with 6w equals 9 minus 15 is negative 6. So dividing by 6 gives me w equals negative 1. Okay, number 9. I'll try to squeeze in over here. 4 minus 3 times the quantity x plus 2 plus x equals 5 times the quantity x minus 1 minus 7x. Okay, again, I'm going to use my distributive property with my negative 3. So 4 and multiplying my negative 3 is negative 3x minus 6 plus x. And then distributing my 5, 5x minus 5 minus 7x. Okay, combining like terms. 4 minus 6 is negative 2. Negative 3x plus x is negative 2x. Negative 5x minus 7x is negative 2x. And then I have the minus 5. No like terms there. If I rearrange this a little bit, I almost have what I had in number 7. Oops. But not quite. So I have the same coefficient on my x, but then I have different numbers as my constants. So what happens is if I start using inverse operations and I add 2x to both sides, because if I have negative 2x to cancel it out, I'm going to do positive 2x. It actually cancels out to say negative 2 is equal to negative 5. That's going to be a no solution. Okay, last I'm going to do number 10. Oh, where can I squeeze this one? I'll have to do it down here and then erase it for number 11. Okay, I have 7d minus 2 minus 3d is equal to 5 minus 2 times the quantity d plus 3 plus 4d. Okay, distributive property. 7d minus 14 minus 3d, distributing on negative 2 becomes negative 2d minus 6 plus 4d. Okay, combining like terms, 7d minus 3d is 4d. Like terms over here, 5 minus 6 is negative 1.